Hi, I'm Akshay. We'll be solving this problem which came into IIT JEE in 1978 year, and this problem corresponds to physics, the topic of physics being kinematics. So, going on the question, a car accelerates from rest at a constant rate alpha for some time, after which it deaccelerates at constant rate beta to come to rest. If the total time lapse is t seconds, evaluate the maximum velocity reached and the total distance traveled. So we have two parts, part A and part B. We'll take two approaches for this question. Both of them are equally good, but if we could picture all of this information in some graphical form, that would make more sense to us, making things more easy to us. So the rate of acceleration is constant. Let us say it travels in two parts. From part A it goes to part C, takes a halt at, or it changes a variable at B. So during A to B, acceleration is plus alpha, and during B to C, acceleration is minus beta. Suppose the time taken in this interval from going A to B is t1. Similarly, the time taken from B to C is t2, and as per the question, we know that t1 plus t2 is given to us as the total time taken is t seconds. So this is t seconds. Okay. Now, if we plot a curve of this, we know that the acceleration is nothing but the slope of a VT curve. So if I have to draw a curve, velocity time curve, so for t1 seconds the car is accelerating, positive slope, suppose theta 1, it reaches this point. Now from this point, suppose it deaccelerates, and this is say theta 2, and in some time after t2, the total interval being t1 plus t2, it finally comes to rest, that is velocity comes 0. Now the maximum velocity reached, which is the first part, is clearly depicted in the graph as we have to find this point. This is Vmax, maximum velocity reached. So from the curve it is quite clear to us that alpha tangent theta 1 in triangle OX, Y, Z, tangent theta in triangle OXY, tangent theta is equal to this height is Vmax divided by T1. Similarly, tangent of theta 2 is Vmax by T2 in triangle XYZ. This comes from triangle XYZ. Then theta 1 came from triangle OXY. Okay, so this gives us that T1 plus T2 is equal to Vmax common cot theta 1 plus cot theta 2. Okay, now we know that tangent of theta 1 is nothing but the slope of VT curve. It is nothing but the slope of VT curve in first half. Now the slope of VT curve is given by acceleration, so tan theta 1 is nothing but alpha. So tan theta 1 alpha is also equal to tangent of theta 1. Similarly, a is equal to minus of beta, which is also equal to tangent of, what is the slope of the line while in the interval t2? It is negative 180 minus theta 2. So it is tangent of 180 minus theta 2. This implies that tan theta 2 is equal to beta. Taking this into account, and a is tan theta 1, we can write cot theta 1 and cot theta 2 values, whereas t1 plus t2 is given as t. So this equation reduces to form t is Vmax into 1 by alpha plus 1 by beta, giving us Vmax as t divided by 1 by alpha plus 1 by beta, which essentially gives us t into alpha beta divided by alpha plus beta. Alright, similarly we have to find the distance in the b part. Now the distance is assuming that the particle is moving along one dimension, so the distance will be equal to displacement. And displacement is given by the area under VT curve. So we have this VT curve drawn here. So the total area under this curve is all the shaded part, which is equal to saying that the area comprises of area of triangle OXZ. And the area of triangle is half of base into height. So the base of this triangle OXZ, base has a length of complete time interval. Base is a time axis. So the complete length of this interval is t1 plus t2, which is t. So the base is t, and the height is quite visible. The maximum height, the height of this triangle of the altitude is Vmax. So this is Vmax. Putting in the value of Vmax from our equation number 1, we get half t square alpha beta divided by alpha plus beta. So this is our answer to the second part.